Hello.
Hello.
Hey, hi. How are you?
I, I am doing well. My name is Sachin.
Yeah,
And you are?
my name is Piyush.
Whoosh, nice meeting you.
Yeah.
Uh,
Hey. So,
so,
seems like
my-
you are first.
wow, okay.
Yeah.
Should we just get started?
Sure. Uh, yeah.
All right. The delete distance of two strings is the minimum number of characters you need to delete in the two strings in order to get the same string. For instance, the deletion distance between heat and hit is 3. Okay, by deleting E and A in heat, I in I and it, we get HT. Okay, in both cases. We cannot get the same string from, if we cannot get the same string from both strings by deleting two or fewer characters. The distance that returns the delete distance between them. And how the function works, analyze its time and space complexity. All right, let me see if I understand this problem a little bit better now that I've read it.
Sure.
So what it's trying to say is that I am given a stir1 and stir2,
Hmm.
and I need to find out how many characters I need to delete from minimum number of characters I need to delete in order to get from stir1 to stir2, right? So
Correct.
I say, so say first string is dog, dog, and the other is frog. I have to delete D, I keep O, and I have to delete G. Um, minimum distance would be minimum number of characters you need to delete in the two strings in order to get the same string. Okay, so I have to actually delete 3 characters in here, and I have to delete 2 characters in here, right? So the minimum distance would, and then to get the resulting string O here,
Uh,
right?
that is not correct, right? The minimum would be O and G. OG.
The minimum would be OG.
So you have to delete D and FR to make these both string common.
Oh, I see. Okay, okay, I see.
So it is not like you have to convert the first word to second word. It is like you have to do some deletions to make both words similar.
Got it. And in some case, okay, I see. And then the other second scenario, I have some and I have some. I have to delete nothing
Yeah,
in order
because
because they're both
already same. Yeah.
already same. Okay, so at first pass, it feels like I need to find some sort of. Okay, let me look at a third example. Sum and thing.
Mhm.
So there is nothing in common between sum and thing. So this is 4 and this is 5. So this is 9,
Yeah.
right?
Yeah.
And then obviously the empty string will return
They are
0.
already equal. Yeah. So
They're already equal. So on first thing, if I think about my inputs and outputs, um, with inputs, my base case would be like one of my corner condition I can check is if it's an empty string,
yeah.
right? So that's uh, checks, input checks, right? Let me just put that here. If it's an empty string, then return 0. If both are empty string.
Hmm.
Um, if one is an empty string, then I just return the length of the other,
Correct.
right? Right? If one is empty, then return the length of the other. And what else? And the output I have to return is the minimum, right?
Correct.
Right. So whenever I think about minimum, maximum, and strings, I always think about this in the terms of I have to try some sort of a brute force solution where I'm trying every single combination.
Okay.
And since I'm optimizing, I have to think about it in like more of a dynamic programming sense. So this problem kind of screams to me like a DP problem. And if I was to think back from, if I'm looking at this problem, what I'm really trying to find is the longest common subsequence between uh, LCM, longest common subsequence between the two given strings. The two given strings. So once I have that, which is in my first case, dog and frog, my longest common subsequence is OG and OG right here.
Mhm.
Like imagine, now let me rewrite this a little bit. When I say common subsequence, say if I have another example, uh, uh, doga, fro, uh, sorry, d, like this, right? Even in this case, right, my longest common subsequence would be O and G, O and G, because
Yep.
that's common between these two guys, right?
Or it
So
can
my,
be DG.
or it can be DG, or it can be DG, you're right. Or it can be DG,
Actually, yeah, correct. Yeah.
right? So so really what I would want to do is find, my algorithm would be to to get the deletions, right? Number of deletions is equal to the length of S1
Mhm.
plus the length of S2 minus the LCM of S1 and S2.
Correct.
That is the algorithm to get the number of deletions,
Mhm.
right? So this is the algorithm I'm targeting for. Okay. Now let's, the beast in the room, the longest common LCS, not LCM,
Yeah.
LCS,
Subsequence. Yeah.
longest common subsequence. Longest common sequence. Okay. So now how do I want to find the longest common subsequence? Generally, whenever I approach a DP set of problems, I always think about it in the sense of a recursive solution, right? Because that's just natural for me to think about it that way.
Okay.
So I'm going to first implement the recursive solution.
Mhm.
And then after that, that recursive solution is going to have a bunch of branches,
Mhm.
right? Which have a time complex, which would, a bunch of branches, meaning that every call of the recursion tree, every choice diagram in the recursion tree will have a multiple choices that I want to try out. And that means my algorithm will run in O of 2 to the power of n times,
Okay.
where n is the length of string 1 plus string 2,
Okay.
right? So let's just say n plus m, right? Where n
Mhm.
equals len of s1 and m equals len of s2, right? 2 to the power of m plus n. Now we can get this better by memoization,
Mhm.
right? And and that would be simply just caching all of the inputs for my recursion.
Okay.
And if time permits, furthermore, we can go
What?
better by doing a bottom-up approach,
Mhm.
right? And then bottom-up approach will require some sort of a, I would imagine a 2D array
Yeah. To store the states. Yeah.
to store all the constraint things, all the
States.
all those sub yeah,
Yeah.
states and sub problems.
Yeah.
And And then furthermore, we can probably optimize even better if our recurrence relation is only looking at one row at a time. We can probably go from a 2D
To
to a
1D.
1D.
Yeah.
Yeah. So this is the path I want to take with my algorithm. Now, what is the algorithm for? Like, does this look good so far? Is there
Yeah.
anything?
Yeah. It
Any,
looks good actually.
it
Yeah.
looks good. Okay. So let me further develop this a bit more for my recursive formula. what would be my recursive formula? One is my base condition.
Mhm.
My base condition would be when string when string 1 is empty, string a or string when the my base condition would be when the index that I'm passing for S1 and the index that I'm passing for S2 are less than 0.
Okay.
Less than 0.
So you're moving from backwards.
I'm going from backwards. Yes, I'm going to work backwards.
Okay.
And so say my Fn is my recursive formula of recursive function. And I pass in an index of S1 and I pass in an index of S2, right? If and then I do something, say I do some work here, and then I call Fn with len of S1 minus 1 and len of S2 minus 1. So if S1 is less than 0 or S2 is less than 0, actually, what am I returning? I have to find the minimum, I have to find the longest common subsequence, right? So
Yeah.
if any of them is empty, there is nothing I can do, right? If
Mhm.
any of these are empty, my longest common subsequence at that my longest common subsequence at that point is nothing, right? 0. So that's my exit condition. Otherwise, if str s1 equals str s2,
Mhm.
str1 s1 and str2 s2, they're equal, then then I then I return 1 plus fn of s1 minus 1 fn of s1 s2 minus 1,
Okay.
right? Otherwise, I'll have a choice to make now. Otherwise, I do a maximum of fn of s1 minus 1 and s2 and fn of s s
1 comma.
s1 comma s1 comma s2 minus 1,
Yeah.
right? Right, that looks right. Maximum common, and this would return 0 and this would return 1. Actually, I'm just wondering one thing. Is this, yeah, it only increases the size if I have a match. If I don't have a match, I just want to recurse down
Mhm.
and say,
To
okay,
find a match. Yeah.
find the match. And then, okay, so this looks kind of good so far. Is it okay if I actually formalize this in code?
Yep. Yep.
Okay, so um, let me create a function called def LCS, and I
Mhm.
pass in a str1, str2, and I pass in a s1, s2,
Mhm.
right? And longest common subsequence, right? And in here, I say if s1 is less than 0 or s2 is less than 0, return 0,
Okay.
right? And then I do if str, let me just actually copy this so I don't have to rewrite this guy. So str1 is equal to this. I return 1 plus LCS of this guy. And otherwise I return max of LCS of this and LCS of this, right?
Yeah.
Now, what I want to do is I want to memoize this guy, so I will just use at functools.lru cache. I think it's false. No, max size is false.
Yeah, it's false.
Yeah. So this will be my LCS function,
Mhm.
and I would call this with longest common sub equals LCS of len LCS of str1, str2, len str1 minus 1, len str2 minus 1. Let me just check this quickly. So if it's less, okay, so I have to pass in minus 1 here because I'm actually checking an index here. Otherwise, I'll get an out of bounds exception. I'm passing string 1, string 2. Let's just, for convenience sake, let's just len of str1 minus 1, len of str minus 2. Okay, this looks good. And my result, as we spoke before, was the deletions equal len of str1 plus len of str2 minus longest common subs, and I return deletions.
Yeah.
This looks reasonable for now. Let me see. Why is this giving me an error here? Okay. So this is a solution. Let me just check this. And
So there is a bug in this solution. If you
it's a
can
bug.
find it out. Yeah.
Okay. So let me just walk through it first,
Sure.
and see what's going on. So I call LCS with stir1, stir2. I'm not passing in stir1, stir2 to both of these guys.
Yeah. So this is the compilation mistake. Yeah. But there is one logical bug also.
Yeah, str1, str2, and I'm also not passing in str1, str2. Okay, so logical mistake. Let me see. Return the max of str1 is equal to str2 if deletions. So okay, let's start with the beginning. I'm passing in str1. I'm passing in the right set of strings here. In here, if s1 is less than 0 or s2 is less than 0, I return 0. If str1 s1 is equal to str2 s2, I call this function again with parameters. I do s1 minus 1 and s2 minus 1. So I'm walking backwards. This looks correct.
Mhm.
Now, what happens if they're both equal? If one of them is equal, okay, let me think about this a little bit further. When in one scenario, if I reach if I reach the end of one string and the other is not the end, I still have to return 0 because there's no more longest common subsequence left.
Correct.
So this condition is correct.
Yes.
Now, the other part is if they're both matching, that is a number I want to increment. So I have to add 1.
Mm-hmm.
So this is also correct.
Mm-hmm.
Now here, oh, yes, there's another one. There's 3 conditions here, actually. So one is I increment 1, I increment the other. Sorry, I decrement 1, I decrement the other. And the third condition is I actually decrement both.
So how
That
is this different from your 69th line?
In this case, they are both. So this is different from the 69 case is that I could have a situation where both characters need to be deleted simultaneously. Like they're not matching. They're not
So
matching each other.
will they not be covered by 72 and 73rd line?
Yeah, actually, you're right. They would be because in one case, yeah, you're right. I would not need, no, I would not need that. I would not need that. Hmm. Where would I be missing this?
I think if you do a dry run, then maybe you can catch it.
Like a basically walk through
Yeah,
the steps, right?
walk through a sample. Yeah,
So let's do the walkthrough. So let's do dog and frog,
sure.
right? So first case, I send in uh, 2. So S1 and S2, S1 and S2 will be 2 and 3.
Hmm.
And then they're not less than 0. So I come and they're not, and G and G match,
Yeah.
right? So I would at line 74 or at line 75,
Hmm.
75, I would, oh, it's kind of funny actually. If I keep moving the cursor, that's the line. Let me just do this dry run underneath so that
Sure.
my line numbers don't actually fault on me right here. What did I do?
Uh,
I think it's just a thing.
oh, it's a single quotes. Okay.
Yeah. Okay. Yeah. Sorry. I use like with the dry run. Like I want to keep track of my lines, otherwise they will go.
Sure, sure.
Will be lost. So 68. At 68, S1, okay, S1 is 2, S2 is 3, which points to G and G, right? At
Hmm.
68, they match. So I return 1 plus, and I call the function again,
Hmm.
right? So I will be, I'll add a new stack frame. So S1 will be 1, S2 will be 2,
Yeah,
and that will be O and O, right?
yeah, yeah.
And I'll come back at 68 again, and I will add 1
One.
plus that, right? So that's 2. And I'll
Yes.
recurse again. And now will be S1 will be 0, S2 will be 0,
Hmm.
and that would be
No, S2 will be one, right?
S2 will be 1. So S2 will be 1. So S1 will be D, and S2 will be R. They
Hmm.
don't match. So now I go to line 70, where I'm returning um, max of max of the first LCS, so S1, which is going to return 0,
Mhm.
and the other one will return 0 as well, right?
Okay.
So, so that will return to me, oh, I need to add a 1 here.
Mm, why?
No, I don't need to add a 1 here. So max of 0 and 0 will give me, oh, wait. Equal to 0. Result is equal to this, and result is equal to this, and then I return result.
Uh, so
That
let me give you
same
a
thing.
hint. So the like in your LCS function there is no problem. Like I think there is no problem. There is a bug in 78th line if you can catch it.
70. Wow, okay. 78 line. Okay, so length of string 1 is going to give me 3, 3. Length of string 2 is going to give me 4. And longest common subsequence is going to give me, it's going to give me 3, right? So 3 plus 4, 7
It will be two,
minus,
right? LCS for dog and frog.
oh yeah, sorry. It'll be, yeah, it'll be 2. So 7 minus 2 will give me 5. Oh, silly me. I need to take the maximum of the length of these guys.
Oh no 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 no.
Oh no,
So this is
no,
not
wait.
it. So you are deleting the longest common subsequence only once, right? So you have to delete it twice,
Twice. Yes, I need to delete it once from the string 1, and I need to delete it once from the string 2 to get
right?
all of my deletion.
Correct.
Okay. So 2 times. Yeah, that would be clearer. Yeah. That, so actually my initial logic was up here. Number of deletions is 2 times because I need to actually remove the deletions from the length
Both.
of S1
Yeah.
and the length of S2. So this is where I was missing.
Yeah.
Yes. Ooh, okay. That, yeah, and then this didn't make a difference, right? The result
Yeah.
I could just return directly here. Return, and I could return. This would make things
Okay.
shorter. Okay, so I can try this dry run, run this, see if this passes the test cases, and then we can
Yeah.
try the deep approach of this guy. So run
Oh, you have
func.
to include functools, right? You have used LRU cache.
Oh, you're right. Import func tools. Yes. Import func tools.
Is it in functools or some other? I think like for this, there is some other module, right? I don't
Um,
actually remember. I used it
you know
before,
what?
but yeah. Let's remove it
Um,
actually. Let's just check like if the logic is correct or not.
yeah, let's just remove this for now. I'll convert it into DP.
Sure,
this,
sure.
this is when you try to get a little too fancy ahead of yourself.
Yeah.
Okay, so let's see if this works.
Oh,
Okay, all the
nice.
test cases
Yeah.
have. It's
So,
surprising because I actually did not test my first case where it's empty string. Yes,
yeah. No,
uh,
so it will be, cached, right?
it'll work
So,
out. Yeah,
yeah,
it'll work out.
yeah.
So that's good. Now let's take this a step further, and let's make this into actually bottom-up DP approach. So def.
So let's forget about bottom up. So can you do the memoization here itself? Like, don't use the
Yeah,
function, and if we can do the memoization, I think bottom up also will be like same similar approach, right? You have to
Yeah, I mean,
create a array from the back end.
yeah. Memo. So I can just create a memo, which is this, and I can pass in a memo as my parameter,
Mhm.
and say if memo is here, same memo, and then I do. I could have made this an inner function as well, but then I've been given feedback that usually having separate functions is better.
Oh,
But
actually, I generally use the inner function
yeah,
just to
that,
save,
that was
some
that's
parameters.
yeah. It's like I wouldn't have to type in the string one,
Yeah,
string
yeah,
two, but that's fine.
yeah.
Um, memo is okay. Key equals s1, s1, s2. If key and memo return memo key, otherwise let's just do result is equal to 0. Result is equal to this guy, and result is equal to this guy, and memo key is equal to result, and return result. So this would memoize this guy.
Okay. Um, so would it be better to have a 2D array rather than comparing the strings all the time? Oh, you are making the tuple, right?
I mean,
Yeah.
yeah, I'm making a couple of indices,
Yeah.
and I'm only adding. So I'm essentially using the a dictionary for memo instead of
Yeah, yeah.
pre-allocating
Correct.
a full-on array. Um,
Yeah, I think it is like the same.
yeah,
Having a 2D array.
it would yeah, it would be roughly the same as complexity wise.
Mhm.
Um, so that ran. Um, do we have time? Actually, we are kind of running out of my time.
Uh,
Any quick feedback comments?
so I think you solved it logically correct, right? So you followed all the approach that we should follow, like for the question. So you have gone with the sample examples, and then you told me the algo, and then you basically wrote the code. So I think I'm good. Like you are fine with, just like there was some bug which I wanted, like you would have cached on yourself, but yeah, this longest,
Yeah, this is
yeah.
the funny thing. Yeah, this is I actually my
Because
initial
you
development of the
actually solved everything correctly, but then you fall back in the simplest line on the 86.
yeah,
So
like my first line was actually like the algo was yeah.
yeah, so it's
It's a good
fine. Yeah,
problem.
yeah,
All right, ready to swap roles?
yeah. Sure.
Let's do it. Uh,
Uh, okay.
number of paths.
Okay. So you're testing a new driverless car that is located in the southwest bottom left corner of an. The car is supposed to get to the opposite northeast. Given n the size of the grid, write a function number of path to destination that returns the number of possible paths to the driverless car can take. For the convenience, let's represent every square in the grid as a pair of I and j. The first coordinate in the pair denotes east to west axis, and the second coordinate denotes south to north axis. Okay. The initial state is of the car is 0, 0, and the destination is n minus 1. N minus 1, the car must abide the following rules. It cannot cross the diagonal borders. In other words, in every step, the I and j needs to maintain, like I should be greater than equal to j. See the illustration above. Okay. In every step, it may go one square up or one square right, but not both. Example. Okay. Explain the correctness of the function and analyze the time and space complexity. So the input is 4. Okay. So what I understood from the question is basically you are given a matrix, right? 2D matrix, and your car is basically at the position 0 comma 0, right? And you have to reach to n minus 1 comma n minus 1. And the only one condition that we have is we cannot cross the diagonal. So the condition is like rightly said here, right? So I should be always greater than equal to j. And then you have to count the number of paths available, and then you have to just return it, right? It should be a number, so you don't have to trace that path. You just know like if I can go there or not, right? Okay. So basically this also seems like a DP problem, right? So
UP's everywhere.
yeah. So so basically how we can do is so let's take a simpler example, right? So if n is equal to 4, so there will be, let me just create something like this, 0, 0, 0, 0. So this will be my initial array, right? And it's a square matrix. So here, so now I am at this position 0, 0, and I can only go up or I can go right, right?
Yep.
And there is one more condition, like I cannot cross j, so I should be always greater than j. So here if I am here, so there is only one possibility, so I can only go right, because if I go up my condition will fail. So here I can update like 1, right? So now from here I can go up or I can go right, right?
Yep.
So here it will be 1, and here it will be 1. So I think it is for here, it will be like I can go from, I can, so actually what I'm trying to say is at this coordinate from where I can come, right? So I can come from here or I can come from here. So it will be like 1 plus 1, 2, two paths here.
Yep.
And then in here also, like I can only come from bottom in this particular place, right? So
So one question, you can be on the diagonal. Okay, yeah, you can be, yeah,
I
you can
can
be
on
on
bidder.
the diagonal.
Yeah,
You can be on
I
the diagonal. Okay,
cannot
that's fine.
cross actually.
You cannot cross, yeah.
So here basically, so the recurrence relation that I can see here is like if I'm at any particular coordinate, right? So I can come from left or I can come from bottom. So basically my A of current position, which is ij, it will be like the path from A I minus j, sorry, A I minus 1 j plus A I j minus 1. Um, but there is one condition, like I should be greater than j, greater than equal to j. So if I minus 1, like basically if violates this condition, then I will not add, right?
Yep.
And if I do this and if I reach n by n, then basically I will have like all the paths, like number of all the paths that I can have. So let me just complete it just to prove like it is correct.
Yep.
So here I can only come by 1, then it is like here it is 3, then here it is 5, and then here it is 5. So it is correct, right? So I have to, the intended output is also 5.
Yep.
So
You got it.
so this is like a bottom up approach.
Yep.
And so does this seems fine to you? I can start code.
Yeah, yeah, this looks good.
Okay. So basically what I want to do is I can create an array, right? Um, So this will basically create my 2D array of containing all the zeros, and my initial position will be it will be I should be 0, j should be, so I can go from top to down or uh, from bottom to top. It doesn't make any difference. So let me just start from 0 0 itself, just for the sake of
Yep.
simplicity. And my end goal will be like nn, right? So from top to there. So for I in range, then of, or I can just say n for j in range. So I will always start j from I itself, so that I am always on the diagonal, right?
Oh yeah.
Uh,
Okay.
yeah, so that I am not traversing that path. And let me just declare a variable result which will contain the count. Um, I don't need it actually.
You don't need
So here, if so, this is my condition that it should satisfy.
Yep.
Is greater than equal to, j should be greater than I. Okay, so I can initialize actually array of 0 0 to 1, and then so basically the rationale here is like, if I'm at that point, so there is only one way I can be at that point.
Yep.
Then I can start from here. So if I'm here, this will be like 0 1. This will be like 1 1 1 0. J is I comma 1.
Is equal to 0.
Okay, so let me just do the dry run. Actually, I'm not sure if I've done the indexing correctly or not. So
Okay.
let's just do the dry run and then figure it out. So let's take a example of 4 itself, right? So 0, 0. Let me just copy it actually. Okay, uh, 0, 0, and so basically my index I is currently 0 and j is currently 0, right?
Yep.
Now I'm into this loop. So I'm checking like, okay, if I is equal to 0, and I'm also initializing like array of 0, 0 to 1. So this is basically 1 right now, right?
Yep.
So now this condition satisfied, it will continue. Now j becomes 1. So now I'm checking like if 0 minus 1 is less than j, which is correct, but 0 minus 1 is greater than not. So this condition is not satisfied, right? So I will skip this because I minus 1 will be negative 1 right now.
Yep.
Then I can go to this condition. So basically j minus 1. So 1 minus 1 is greater than or equal to 0, which is correct. And j minus 1 is also greater than or equal to 0, which is correct. So this condition satisfies. And then my array of 0, 1, right, which is 0, 1 here. It will be plus is equal to array of I, which is 0, and array of j minus 1, which is 0. So it will be 1, right?
Yep.
Now the j will be 2 right now. So again, so this will be like for this complete loop, like this will not be considered because I minus 1 is less than 0.
Yep.
And for this particular thing, it will be like just keep on adding previous one. So it will be like 1 and 1, right?
Yep.
I'm sorry, I'm going fast, but yeah, it will be
No, no,
something.
no, no. I can follow you. I can follow you.
Okay. So now my I will become 1, right? And my j is 1 because I'm starting with
So this
I.
this matches your original here. It's just the flipped around it, right? So this
Yes,
is you're basically building this backwards in a way,
yes, yes, yes,
right?
yes.
So
Like actually, I have a like sense, from 0 to n, n it like it logically comes into my mind. So that's why I just
no, no,
flipped it.
no. That's fine. That's fine. This is
Yeah.
good.
So basically, I is equal to 0, j is equal to 0. This is false. This will be false for the whole now. So now I minus 1 is less than j, which is correct because 0 is less than j. And I minus 1 is also greater than or equal to 0, which is also correct. So now array of ij, which is 1, 1, will be plus is equal to I minus 1, which is 0, and j, which is 1. So it will be, so 0, 1 here is here, right? So it will be
Yep.
plus is equal to 1 here. Then I will come to this condition. 1 minus 1, 0 is greater than or equal to I, which will be incorrect, right?
Yep.
So
It won't do anything.
this will be failed. So this is here it will be only 1 right now.
Yep.
Now my j will be 2, and basically this will pass, right? So I minus 1, similar condition. So this will pass for everything. So it will be just adding the above thing. So for the first statement, it will be like 1.
Yep.
And for the second statement, now j is 2. So 2 minus 1, which is 1, which is greater than or equal to I. So this passes. And j minus I is greater than or equal to 0, which also passes. So basically, a array of ij is plus is equal to array of I and j minus 1. So which is array of I, which is 1, and j minus 1, which is 1. So this thing.
Yep.
So basically, it will add it, and it will become 2. So I think like
Yep.
this will pass if I
Yep.
continue. So
Yeah, this looks good.
do you want me to run the tests just to verify?
Um,
And there
just
is one edge case. Basically, if n is equal to 0, you can just return 0.
yeah.
And for 1, it should work because this loop will not run, and it will return n minus 1, which is 0, which I am setting here itself. So it will be
Yep.
1. So
This looks good.
Okay, let's try to run it. Undefined. Nice.
Actual return defined
Number of
one.
paths to destination.
Index out of range.
N is equal to 1. So n is equal to 1 here. It will not return here. Now 0.
Oh, yeah.
Yeah,
N
this
minus,
this will,
this is,
yeah.
do you need n minus 1 or do you need n?
So this I need n, right?
Right? You're creating an, yeah, there
Yeah.
you go. Perfect.
Actually, yeah. This was a silly mistake. Yeah, zero based indexing. And
Can you comment on the time and space complexity?
yeah, so the worst case time complexity will be n square because I am iterating over. It will be basically n square by 2 because I'm only iterating the half of the array, but like it is like n square itself. So the worst case will be n square. The space complexity is n square here also because
Okay.
I'm recreating an array, right? Just to calculate it.
Okay. Um, now, so going from n squared space complexity, could you go better?
Okay. Space complexity you're saying, right?
Yeah.
Yeah. Yeah, actually, I can go better because for every row, I only need the information of the above row, right?
Yeah.
Just to add that. So
Yep.
basically, I can, maintain only two rows, or you can say I can maintain, yeah, I can maintain two rows just to calculate it and update it, and then I can just do that for like for every iteration, and then from that I can save the space.
Okay. This looks good. Yeah, like I guess my feedback for you, you did a fantastic job of initially, creating this grid.
Hmm.
So first thing is you recognize that this is a DP problem right away.
Okay.
And one thing that I think you did better on than I did actually when I did this problem was I actually went for this recursive solution, right?
Yeah.
Whereas you actually said, okay, this is a path-based problem, and it actually almost naturally feels better to look at it at a bottom-up approach,
Yeah.
right? So this thing that you did here was fantastic because you just started and then you built the solution as you went along and you ended up with it. So you had a very good, clear recurrence relationship, and then you posted that here.
Yeah.
Um, and then that just sets you up for success afterwards, right? It basically, you knew your array. Another thing that I feel that you did really well on was this thing. Um, like when I did this, I basically just blindly did n by n. Whereas you recognize, hey, I can't pass my diagonal, so why bother even looking there?
Yeah.
So that was a really good one. Um, and yeah, I mean, there's not much more I can say. You were clear through the whole. I could understand everything that I could hear from you. Um, yeah, like, do you mind me asking how far along you are in your prep, or what's your current?
Oh, so actually, I'm not uh, looking for a switch. So I actually recently switched 4 month back itself. So this is basically for fun for me.